Hey guys, in this video we'll be just looking at just a couple of questions from exercise 3M, which is to do with calculating the length of a shorter side. Let's have a look at question 6. In this case, we've got a circle's diameter AC, which is 15 centimeters, and a chord AB, which is 9 centimeters. Okay, so here's my diameter stretching from one end of the circle to the other end of the circle, and it's the longest chord that I could have in a circle. Okay, so chords are just lines like these, going from one point to another point of the circle. Okay, so that's the longest one. Now there's another chord here, which is 9 centimeters. Okay, and angle ABC apparently here is 9 degrees. So find the length of the chord BC. So this length here, right? So this is very simple. This is a shorter length because opposite the 90 degrees, this has already taken the form of the hypotenuse. So we know our formula a squared equals to c squared minus b squared. But in this case, I'm not going to use a, c, and b. I want us to use two letters that denote each side. So we're trying to find out what this length is, which we can call BC or CB. So we can write BC squared, and that would equal to AC squared, if you want to write that down, minus AB squared. And then simply what we do is we keep writing that BC squared. AC squared is going to be 15 squared minus AB squared, which is 9 squared. And so on the calculator, 15 squared minus 9 squared is going to give us 144. So if I take the square root of both sides, applying the square root of BC squared will be BC, and the square root of 144 would give us 12 centimeters. Okay? So that's the length of BC. Right. So let's go to our next example, which is question 9. Okay, question 9 is just part of the working out that a lot of students do that I think they occur very often, and it's some mistake that I'd like you to rectify and change if you do these mistakes. But let's identify what kind of mistakes these are. So for every problem here for A, B, and C, the second line is where the problem occurs, okay, according to the question. So we've got A squared plus 10 equals 24, and then they wrote A squared equals 34, okay? So what do they do here? And what are we meant to do? We're meant to do a minus 10 to both sides, like that, okay, such that these two cancel out, and that would give you that A squared, which is correct. But 24 minus 10 should give you 14, which is not the case. So what can you describe here that they have done instead of subtracting 10? They have added 10. So the answer for part A is they have added 10 instead of subtracting 10. And what do we call this? Okay, which side of the equation is this? We can say it's subtracting 10 to the right-hand side. And you're allowed to write RHS. We understand that. Now for question B, they wrote A squared equals 25, and then nothing equals 5. So you can see it and identify straight away that there's nothing here, and there has to be something here on the left side. And if you don't write that, then what this means, if you keep writing equals, 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 and there's something here, something here, something here, but nothing on this space here, what we're trying to assume then is that this A squared is now here. So you're telling me that A squared equals 5, which is not correct. And this is something that a lot of students do. You have to write down A, okay? Because the step here from this step to this step is to apply the square root both sides. And when we apply the square root to the left side, we have an A left. We don't have A squared anymore, and the square root of 25 becomes 5. So it's important that you write the A there. Okay, so this one we don't have to really explain that. We just write that there. Whereas for question C, we've got the student saying A squared plus 25 equals 36. Okay, that's our question. But then in the next step, what they've done is they wrote A squared plus 5 equals 6. So what have they done wrong? They have taken the square root of 25 to become 5, and they have also taken the square root of 36 to become 6. And you can't do that. You can't square root any kind of numbers randomly in a number sentence like that. Okay? When we take the square root of both sides, we can only do it to this. And that means applying the square root to both a squared plus 25. And by the way, this is not equal to a plus 5. You can't square each of these individually. Okay? You learn a bit more of that in index laws and surds, which is not now. So the correct way of doing this is subtracting 25 to both sides. Okay, that's the first thing you do. Okay, so you can just say here that they have taken the square roots of 25 and 36. Okay, so these two applied with the square root becomes 5 and 6. Okay, they shouldn't have done that. Whereas they were meant to do, or meant to subtract 25 to both sides. Okay, so they're meant to do this. They're meant to subtract 25 to this side, subtract 25 to this side, so that this cancels. All right, and those are the common mistakes that appear in Pythagoras' theorem.